Robert Boutillier. Content analysis is the reading of texts with the aim of identifying what themes, concepts, and words it contains, in what proportions, and in what relationship with each other. It produces useful insights about how the people who produce the texts see things. For example, text from the websites of newspapers and television channels might be categorized into different themes on some controversial topic. These themes explain the conflicting positions on the topic, and their relative prevalence can be linked to increasing or decreasing support for one side or the other. Until relatively recently, all content analysis was done by human beings reading the texts and inventing categories into which they could place the idea expressed. This is a very laborious process that can take anywhere from several months to over a year. Therefore, most texts remain unanalyzed in any rigorous way. And now, with the nearly worldwide use of social media and internet communications, we're generating even more text than ever. That means that there are even more insights going undiscovered. Fortunately, we now have technology that can simulate the categorization that humans do. Before we get into that, though, let's look at a sampling of the many diverse situations where automated content analysis can help make better decisions and devise better strategies. Content analysis provides insights in any field of human activity that could involve text, whether that text comes from the internet, printed material, or transcriptions of audio from videos or radio broadcasts. For example, during natural disasters, it can quickly analyze the content of hundreds of thousands of social media posts to detect areas needing extra emergency attention. It can be used to summarize the main themes of reports or books. Marketers use it to discover the motives and values of various subgroups of consumers and to keep track of trends. Policy analysts in government and think tanks use it to extract policy problems, controversies, and directions. It's very heavily used in public affairs and community relations to discover controversies and to develop solutions. Let's look at an example from Brazil that nicely shows the insights that lie hidden in texts from social media. Hortelato and Moreto Ribeiro used content analysis to classify the Facebook pages of Brazilian activists and politicians in 2013 and 2016. In 2013, they found 6 clusters of pages cross-posting amongst themselves. 2 were political parties and 4 were social issues-oriented clusters. In 2013, there were links amongst the clusters that crossed the left-right political divide. In 2016, the political landscape had become so polarized that the clusters of activists had sorted themselves into meta-clusters according to their alignment with a political party. This kind of analysis can help public affairs professionals understand the opportunities for and barriers against the building of bridges to form broad-based coalitions on public policy matters. As these examples illustrate, the insights locked in texts from diverse sources could yield very strategic insights if only they could be extracted fast enough. That's where automated methods can help. Software programs for telling us what large volumes of text contain come in many varieties. Perhaps the most famous example is sentiment analysis applied to extremely large volumes of social media text like Twitter posts. In 2011, Kalev Litaru predicted the first Arab Spring uprising in Egypt by looking at the positivity versus negativity of thousands of social media posts. The method detected a change in the social political environment that was missed by all the intelligence agencies in the world. Now, sentiment analysis is used by most large consumer product and service companies to track customer satisfaction. For distinctions other than like-dislike, the most popular approach involves artificial intelligence algorithms known as neural networks. Unfortunately, they require huge amounts of data. In the case of neural networks, there also has to be a large data set that has been pre-coded by humans to be used as training data for the machine learning. Controversies around the operations of resource companies seldom generate huge volumes of social media posts or any other kind of text for that matter. These companies need automated methods that work with smaller data volumes. Fortunately, the approach known as natural language processing, or NLP, works on datasets of any size. Moreover, the technology is improving quite rapidly. The assumption underlying the bag of words approach to NLP is that each theme uses a distinctive cluster of words. Programmers call such clusters bags of words. If a bag of words is found, it's likely a theme, but a human will have to decide what to call it. Bags of words evolve across time and differ across subgroups and coalitions. The bag of words approach requires some preparation of the text to be analyzed, but this text preparation is semi-automated. To prepare the text, first you have to eliminate the punctuation and the non-thematic words. These are called stop words, and standard lists of them are available for free in all the major languages. Next, you reduce the remaining words to their root form so that you can capture all the variations associated with verb tenses and parts of speech. Then you attribute a link between two words if they appear next to each other, or sometimes within two places of each other. Then you count the number of times the words are linked to each other. This produces the clusters, or bags of words. Some clusters will be more tightly connected internally than others, and there's automated metrics you can use to discover this. Then when you have the clusters, or bags, you can look at the links among them, which gives you information about the narrative that it comes from. For example, if you find a bag of words about water and a bag of words about health linked to each other, you might look further for a narrative about polluted drinking water. We've developed a program called SLaCDA that does all this. The acronym SLaCDA stands for Social License and Controversy Detector and Analyzer. Here are the steps it goes through. First, you collect data from stakeholder interviews, tweets, news articles, etc., and compile these into a single database as a list of discrete responses. You break longer texts into relevant sentences that can be analyzed individually. Next, the program cleans the data by removing punctuation, standardizing the spelling where possible, specifying stop words, and combining compound words or phrases. For example, it converts the two-word name Rio Grande into just one word. Then it splits each text into a list of words and standardizes word forms using just their root stems. The output from this stage is a list of only relevant words for each stakeholder response or chunk of text. This step takes 80% of the time in doing an analysis, and if there are problems in the final analysis, this is one of the first things you go back and check. The next step is where the clever bit begins. SLaCDA generates a new set of documents using latent Dirichlet allocation, or LDA. This creates the same number of lists of words as there are original documents, but because it's random, the probability of matching the original documents is quite low. These arbitrarily created documents are generated using a given distribution of topics over documents and words over topics. Those distributions are the crucial variables that you can then manipulate. The parameters of these distributions are systematically changed in order to maximize the probability of creating the original documents. The distributions that maximize that probability give us the topics for each document and the words for each topic. Once the topics and words are determined, SLaCDA searches the original texts for the words listed in each topic bag and characterizes them as belonging to one or more topic. If a text is associated with more than one topic, those topics are considered to be related to each other or linked. Because of the high probability of all topics being mentioned together at least once in a large set of texts, the co-mention frequencies are normalized so that only the topics mentioned together a statistically significant number of times are deemed to be connected to each other. These connections form the basis for a network graph in which the nodes are topics and the links are the frequency of co-mentions between pairs of topics. The LDA model in step 3 requires the user to choose the number of topics that they think the corpus of documents contains and the number of words that are in each topic. Those choices might not have been optimal, and so after running the model, a subject matter expert assesses the fitness of the topics and words. If the bags of words don't make sense, then the number of topics and words is changed and steps 3 to 5 are run again until the user is satisfied that the bags of words make sense and the topic graph can be analyzed. If you've done content analysis before, you might be skeptical about how counting words can produce the same interpretation as humans produce by reading text for meaning. We tested the performance of the bag of words approach, comparing it with coding done by humans. The text came from 8 years' worth of interviews with stakeholders of a mine in Bolivia. There were 4 subgroups that produced mean frequency of mention scores for the theme of water. This graph shows how closely the 2 coding systems coincided. The correlation was 0.95, which is extremely significant. Of course, with more training and more time, the human coding can make finer distinctions about what was being said about water. However, you need this general level of analysis first before you can decide if finer distinctions are worth quantifying. On the same data, SLaCDA identified a bag of words we labeled as water consumption and another labeled as economic benefits for families. We compared their frequencies across the 8 years with the frequencies that humans noted for a topic called water supply and one called promotion of economic development or projects. As the graphs show, the results produced by the methods were quite significantly correlated. Mentions of water issues decreased and mentions of economic benefits increased. SLaCDA can also track the evolution of narrative networks, as was done manually in the case of the political polarization in Brazil that I talked about a few minutes ago. In that case, the Facebook pages were classified into 6 categories of topics by humans who read the text on the pages. That's a lot of work and takes weeks to do. SLaCDA can do it in a few minutes, although it would probably take a few days to obtain all the text and format it as input data. Days instead of weeks makes the results much more relevant for decisions about social media strategies. In the Brazil case, the ties among the clusters of topics were based on the number of visits from one page owner to the page of another. SLaCDA can do similar things where the data is available, but can also link the clusters of topics according to the amount of shared content as indexed by the patterns of shared words. In the Brazil case, the researchers decided that there were 6 clusters of topics. SLaCDA can be adjusted to extract as many or as few as are necessary to improve the interpretability of the bags. Sometimes it will even discover new topics that the researchers hadn't noticed before. For graphing, the Brazil case was dimensionalized with the horizontal axis representing the left-right political spectrum and the vertical axis dividing politicians from civil society actors. You can do the same with the topic bags produced by SLaCDA, or you can choose to let the program discover what the latent dimensionality is among the bags. That way you often discover new ways of thinking about the main differences among the topics and the groups that mentioned them. Well, that's how you can get more insights out of anything that can be represented as text. With the automated methods available today, it doesn't take weeks or months. Once you have the data stream set up, it's a question of hours. We can help you with a one-time project or to set up a program that will let you bring it in-house. Thanks for watching.